What's up? Let's do this. New video here. 2022 video. Because I think I'm doing a better job of teaching this than I've done in the past. Explains how calculus helps you understand motion and physics better. Well, it's the whole idea. It's like we're used to f prime, f double prime. And then we have these terms like position, velocity, acceleration. But it turns out it's the same. If you're thinking, and this is the key to this entire unit, is like a dude's on a line, and dude's moving back and forth. Okay, and he starts with a position, like where he's located. He might be to the left of the origin, to the right. If we know how quickly his position's changing, if we know the rates of change of position, we'll get like a velocity, like which direction he's going in and how quickly he's going, a rate of change. So the derivative of position is velocity. If we know how quickly the velocities are changing, we'll figure out how velocity is changing. The rates of change of velocities are accelerations. V prime is a, or since v is x prime, v prime or a is x double prime. We have situations where we have the same thing. This is really like a repeat of unit 3 and unit 6, just it looks different. Okay. Now, this first question, I apologize, is a calculator question. I thought it was going to work out nicely, but it doesn't. So um, here we go. Now, rates of change. You can have an average rate of change or an instantaneous rate of change. First question I have is asking you for an average velocity. Okay. Average rate of change of position would give you an average velocity. If velocity is the derivative of position, like we could look at the derivative of position to get an exact velocity. But here I'm asked to find the average velocity. The average rate of change of position is an average velocity. So I need x of 2 minus x of 0 over 2 minus 0, just like what we kind of did in class. 8 minus 12 minus 12 is 8 minus 24, which is negative 16, over 2, which is negative 8. And it's meters and per second to help. Meters per second or whatever. I don't even tell you what it is. Units are not that important in this class. 8 minus 12 minus 12. So 8. No, I was wrong. Oh, yeah, negative 16. Okay. All right, what's the equation for the exact velocity acceleration? Well, it's like the instantaneous rate of change. I don't want to get too crazy because it is simple once you figure it out. Instantaneous rate of change of position is instant velocity. Remember, average rate of change, you use the slope of the secant. You use a slope formula for an average rate. Rates of change are slopes. Average rate of change, slope over an interval, slope of a secant, lose the slope formula. Instantaneous rate of change, slope of a tangent. How do you find the slope of a tangent? Use the concept of a derivative. Okay, so x prime is v. X prime is 3t squared minus 6t minus 6. And then the same goes with the instantaneous rate of change of v is a. I'm going to go ahead and just go and use x prime and x double prime a lot in the video, even though you can switch over to just like x, then v, then a. But just to make it seem like it's the same stuff that we've done before, I'm going to stick with x prime, x double prime. So velocity at t equals 1 and t equals 2. So v of 1, it's the same as x prime of 1. You don't have to write this, but it's fine. 3 minus 6, which is 9, negative 9. V of 2, I'm not going to write x prime of 2, but I can, is 12 minus 12 minus 6, which is negative 6. What's the acceleration of 1? Acceleration is just second derivative of 1, which is 0. Acceleration of 2, plug in 2 here, 6. Okay. What's the particle moving to the left? Okay. Now this is when we have the friend that we've used in the past, x prime, which is telling us about x. We looked at signs of derivatives to tell us about things increasing or decreasing. Okay, well, if we keep in our brain the dude on a number line, if his position is increasing, okay, thinking about the order, if the position is increasing, we're going from negative 3, negative 2, negative 1, 0, 1, 2. What's happening? He's moving to the right. So I'm going to keep this in here, position's increasing, but I'm also going to throw in that x prime, which is v. If my velocity is positive, I'm moving right. If my velocity is negative, I'm moving left. If my position is decreasing, I'm moving to the left. So velocity is negative. That's what I want to figure out. Now to figure that out, we got to take my velocity, set it equal to 0, and do a sign analysis, just like we used to do. Now this is where I make a boo-boo. This is why we have to use a calculator. 3t squared minus 6t minus 6, set equal to 0. It's not going to be nice to solve. If you pull out a 3, you get that. Can't factor this to solve this, unfortunately. Two numbers that multiply to get negative 2 and add to get negative 2 don't exist. So I'm going to use my calculator for this. I knew this was coming. I apologize for this. 3t squared minus 6t. I'm using x's. Same thing. Minus 6. I'm going to graph y equals 0. Remember how we solve equations? We can graph y equals the left side, y equals the right side. Find the intersections. I got negative 0.732. And this is the graph of v. This is v, right? This is x prime. This is v. Okay, so this is x prime, which is v. And then second calc intersect. Pop over there. The other equations work out. 2.732. Okay. And we can kind of see at the graph where we can just guess. You saw that the values of my velocity, positive values, negative values, positive. So we got positives, negatives, positives. That is telling me my position's increasing, decreasing, increasing, but it's more importantly telling me that I'm moving to the right, to the left, to the right. Okay, if my position's decreasing, the dude on the number line, position's decreasing, you're moving left. So negative 0.732, whatever that other is, and 2.732. Okay, now when's velocity increasing? Well, this is where I break out my friend, when is x prime or v increasing? I'm going to stick with x prime. I think it makes more sense because it's something familiar with us. Since v is x prime, I'm looking for when x prime is going up. This is where we bring our second derivative sign analysis. X double prime, when is that positive? Okay, so really, I need to figure out when acceleration is positive. That's going to tell me when velocity is increasing. Acceleration is the derivative of velocity. How do you figure out when something's increasing or decreasing? Look at when the sign of its derivative is positive or negative. We have the acceleration formula. It's 6t minus 6. So x double prime is 6t minus 6. We'll do a sign analysis with this. We get t equals 1. Got 1, not 0, 1. X double prime, which is a, is positive and negative in that direction. That's telling me x prime, which is v, is decreasing then increasing. V is increasing for t is greater than 1. When is speed increasing? All right, this is when we have to think about the dude and what's going on And a lot of people think it's acceleration is positive. It's like acceleration's got to be positive. Well, what's acceleration really? It's actually just like the change of my velocity. If acceleration's positive, my velocity is increasing. Well, the problem is if my velocity is increasing from -3 to -2 to -1, I'm not really speeding up. I'm slowing down while I'm going to the left. If my velocity is increasing, though, from like 1 to 2 to 3, then my speed's increasing. That's good. I'm traveling to the right, velocity being the change in my position. So I'm traveling to the right because it's positive, and I'm speeding up. But how can I be traveling to the left and speeding up? Well, if my velocity is negative and it's going down, like -1 to -2 to -3, we are speeding up in that situation as well. I showed it to you in class. If you need to look over the video, speed will increase when the signs of V and A are the same. When I'm going right, but increasing with my velocity, or I'm going left and decreasing with my velocity, getting those negative values to be more negative. It's where a lot of confusions with things came from. When we talked about like increasing at a decreasing rate, what does that look like? And a lot of people thought, or decreasing with a decreasing rate. A lot of people thought decreasing with a decreasing rate would be decreasing concave up because it's like you're slowing down, but it's no, decreasing with a decreasing rate is actually speeding up because you're going faster downward. So, anyways, check the signs of V and A. Maybe it's easier to go V and A instead of X prime and X double prime. We had the positive. I'm not going to put the values down. Positive helps it get things in order though. And this is 1. This is positive, negative. So, what are the signs the same? From that negative 0.732 to 1. This is when my velocity is negative. I'm traveling left, but my velocity will be decreasing. So negative velocity is getting more negative, speeding up, going to the left. And then here, I'm traveling to the right, and my velocity is increasing. My acceleration is to the right. Okay, so that's the 2.732 to infinity. And again, this is stuff that we've seen before, it just looks different. All right, now we go backwards. Unit 6. I have A. I have initial velocity and positions. It's very important to understand how you can translate that. And they're asking what's the equations of velocity? What's the equations of position? Let's answer some questions, okay? So initial means at time 0. Now, again, all of these questions is a dude moving right and left, okay? So just make sure, I'm just reminding you to keep that in your brain. If my initial velocity is 3, that means my v of 0 is 3. If my initial position is 4, that means my x of 0 is 4. If I'm given a, what am I given? I'm given x double prime. You want to find v? Take the antiderivative to get x prime. You want to find x? Take the antiderivative of x prime to get x. It's all the same stuff. F double prime, f prime. But don't use f, use x double prime, x prime. Okay, so let's go backwards once to x prime, which is v. We take the antiderivative. Now, this is where stuff gets real tricky, guys, because we're going to be going backwards and forwards all at once. It's not just like keep your mind in antiderivative mode, keep your mind in derivative mode. Be able to go both ways. It is tough. Don't forget your plus c. V of 0 is 3. So x prime of 0 is 3. I plug in 0. I get c is 3. That gives me my equation for velocity, which is the derivative position. That's x prime. Now, we got to go backwards again to get x Position, take the antiderivative. I get 1/3 t cubed minus 2t squared plus 3t plus c. I get x of 0 is 4. I should put this as x of t. These are positions, the position that my dude is located at on the number line at times. That's all we're dealing with. All unit is dudes traveling left and right. It's nice to know that. What's the velocity of t equals 2? What does that mean in terms of direction? Well, velocity of 2 is the same as x prime at 2. That's 4 minus 8 plus 3. That's negative 4 plus 3, which is negative 1. Okay? That means it's the rate of change of position. It's negative. Position is decreasing, moving left. Eventually, like, you'll skip all that stuff I said and just said velocity is negative, moving left. Okay? But it's really like x prime is negative, which means x is decreasing. If x is decreasing, on my number line, my dude is moving to the left. What's the position at 2 and 3? I don't want to find that. I'm not going to. I'm just going to find the position of 3. Do both. Gosh. So 8/3 minus 8 plus 6 plus 4. I mean, why did I give you this? 8/3. Oh my gosh. Plus 2. 6/3. 14/3. Great. 27 divided by 3 is 9 minus 18, negative 9 plus 9, 0 plus 4, 4. It's a particle moving towards or away from the origin at t equals 2. This is great. Don't memorize, understand. If you know your dude, and you know where he's located, and you know which direction he's traveling, boom, you can answer this question. Okay? Don't memorize something, just like understand. It's a dude moving left and right. Well, origin, know where he is with respect to the origin. Know if his position is increasing or decreasing. Know if he's traveling to the left or to the right. Boom. I already know my position in time 2. I found it, thankfully. 14/3. 2. Yep. I know my velocity at time 2. I found it. It's negative 1. What does this mean? And why am I looking at both? You have to look at both. If you just say your velocity is negative, well, if my dude is located to the left of the origin traveling left, he's going away. If my dude is located to the right of the origin traveling left, he's going towards at that moment. So you gotta know the position. My position is positive, which means I'm to the right of the origin at 14/3. My velocity is negative. I'm traveling to the left. He's going towards. When is the particle stopped? When is it moving right? All right, that's when I'm examining velocity. When is it 0? When is it positive? I need a sign analysis of velocity. How do I do a sign analysis of velocity? It's just like what we did in the past. Like you're taking the derivative, you're setting it equal to 0. It's not V's derivative, though. It's like I want V's sign analysis. It's derivative of x. It's x prime. X prime set equal to 0. I mean, it's easy to just like think I need to look at V's signs. So set V equal to 0. V's equation I found was t squared minus 4t plus 3. Oh, I should be at like plus 400%. Whatever. Factor, t minus 3, t plus t minus 1. I got 1 and 3. That's when I'm stopped. My velocity is 0. Signs, positive, negative, positive. How do I know that? Do some test points. We know the multiplicity is 1. Remember all that stuff? It's like if the multiplicity is 1, you just check one sign. You know you're going to change signs. Velocity, we can now say particle increasing, decreasing, increasing. You can, or you could say I'm moving right, left, Right. Now, like, why? Why is it all the same? I gotta do it. I gotta do it because it's so important to not just try to memorize new stuff. X prime signs telling me about X increasing, decreasing, increasing. If my position is increasing, I'm moving to the right. If my position's decreasing, the dude on the number line is moving left. Okay. Particle stopped, t equals 1 and 3. Moving to the right is t is less than 1 and greater than 3. When's velocity decreasing? Great question. Which I'll be able to figure out once my thing stops freezing. Okay, when is velocity going down? Velocity is x prime. When is x prime going down? X prime will go down when x double prime is negative. That's when v prime is negative. I could have gone this way. When v prime is negative, when x double prime is negative, when a is negative. That's how we get that. So we got to look at the equation for a, the equation for x double prime. It's like that whole next level that could tell us about the concavity of x. Curvature, concavity, acceleration. Where was it? A. 2t minus 4. We were given it. T equals 2. 2. Positives, negatives. That's A, which is V prime. It's telling me V is decreasing until 2. Is the acceleration increasing or decreasing always? This is a great question. Is the acceleration increasing or decreasing? How could I figure that out? Well, to figure out if something's increasing or decreasing, you look at its derivative. Guess what? We can look at A prime. What is it? I don't know. It's the slopes of A. What's A prime? It's not V. It's A prime. You take the derivative of A. We usually don't go. This is like a third derivative. This is X double prime. So this would be like X triple prime. But it's a good question. And X triple prime is 2. A prime is 2. So that's positive, which means the acceleration is increasing always. What's your reasoning behind it? Its derivative is positive. When is speed decreasing? Okay, this is when we have velocity values that are getting closer to 0, right? -4, -3, -2, -1. That's negative velocities that are increasing. It's negative velocity, positive acceleration. Or 4, 3, 2, 1, 0. Positive velocities that are decreasing. Positive velocities, negative accelerations. V and A have opposite signs. Okay? And that's my reasoning behind things. And it's fine. I have V, I have A, there's V, there's A. So 1, 3, and 2. Positive, negative, positive. 1 and 3. A, negative, positive. Opposite signs, opposite signs. T is less than 1, 2 to 3. What is this telling me? Okay, this is X prime. It's telling me X is increasing. I'm moving to the right. This is V prime. This is telling me V is decreasing. So I'm moving to the right. My velocities are positive, but they're getting smaller. Positive 4, 3, 2, 1. I'm going to the right, but I'm slowing down. About to come to a stop at t equals 1. Here, I'm moving to the left. My position is decreasing, but my velocities are increasing. So I'm moving to the left. I have negative velocities, negative 4. And those negative velocities are increasing, negative 4, negative 3, negative 2, negative 1. Signs are opposite, slowing down. Okay? Now, I'm going to do these questions two different ways. And these are very important questions because most of the remainder of the graphs given to us and equations given to us always start with, here's velocity, okay? How's my particle moving? Where do I end up? Stuff like that, okay? So starting with velocity is very important to understand. And two ways to do this. Okay, first thing is, when is the particle stopped? And I'm going to do this without doing the sign analysis yet. I'm going to do this like using the charts first, and then I'll show you the same way to do the sign analysis. Okay. Particle stopped when my velocity is equal to 0. Okay, great. That's easy to do. What am I given? I'm given velocity. I'm given x prime. I'm given the derivative graph. When is it 0? This is like the same question as like, when does f have a horizontal tangent? When f prime is 0. It's really the same deal. Right here, and right here. Okay, 0, 3, and 5. My velocity is 0. Okay. When is the particle moving to the left? Okay, well, it's either like my position is decreasing. Oh, that's when its derivative is negative, or we just go straight to, when is my velocity negative? All right, what do I have? I have the velocity. I have the derivative. When is it negative? This is when we realize, oh, let's not look at slopes. We have the velocity. When is velocity negative? When the values of the velocity are negative. So many students have a lot of problems with this because they immediately go to slopes and they say 2 to 4, but no, velocities are negative. And we're underneath, the x-axis, and we get 3 to 5. When is the acceleration negative? Okay. This is a good one. Acceleration's negative. When is acceleration's negative? Well, you could say when v prime, which equals a, is negative. V prime being same as x double prime. I could say, oh, when are the slopes of v negative? Or we could say, if v prime is negative, that means v is decreasing. If acceleration is negative, my velocities are decreasing because it's the derivative. Okay, if we want to look at slopes, or if we want to look at v, it's up to you. I like this way now more than I used to. What do I have? I have the graph of v. Look at when v is going down, or when its slopes are negative. V is going down right there. There's that 2 to 4. Okay. Now the next question, I'll show you two different ways to do it. It might be easy if we have just a full-on sign chart analysis right off the bat. Or we could think, when is speed decreasing? When are my velocity values getting closer to 0? When am I moving right but slowing down? So going 5, 4, 3, 2, 1, 0. When am I moving left but slowing down? Negative 4, negative 3, negative 2, negative 1, negative 0. You could say when my velocity values are positive and decreasing, or negative and increasing. Now, I'd never want you to use this explanation as reasoning. My graph of v is going towards the x-axis. I don't want you to use that. That will not be accepted. You would literally find your intervals and then just immediately say the signs of v and a are opposites. Okay? So that's one way to do it. And then I'm going to show you the other way. So we got 2 to 3 and then 4 to 5. Okay, now the other way to do it is immediately say, oh, I'm just going to throw down V or X prime and its sign chart analysis. Remembering how to do it. It's positive until 3, it's negative until 6, positive after that. I'm going to throw down X double prime, which is V prime, which is A. However I like to do it. Now, some people look at slopes of V. V primes are slopes of V, and they say, okay, positive slopes, zero slopes, negative slopes, zero slopes, positive slopes. Or they say V is increasing, flattened out, decreasing, increasing. However you want to do it, you should get that A's signs are positive until -2. They are negative until 4. They're positive after that. If you can do this, you can answer all the questions in a row. Okay, especially the speed. When are the signs of V and A opposites? V, A, V being the graph you see, A being the slopes. 2 to 3, 4 to 6. Why did I do 6? That should be a 5. Okay. Particle stopped, 3 and 5. Moving left, 3, 2, 5. Velocity is negative. Acceleration negative when V is decreasing, 2 to 4. Speed. Okay. Okay, same questions here. And then we'll get into some free response questions, which we really need to focus on because your entire test is going to be free response. When does the particle stop? Velocity equals 0. Here's my velocity. When is it equal to 0? Not like a 0 time. It's when is the value of velocity 0. That's at 1 and 3. When's the particle moving left? When my velocity is negative. When is my velocity, or when like the derivative is negative? I keep doing this because it's like so important. If the derivative is negative, position is decreasing. If the position is decreasing, you're moving left. You don't have to always say that. You can just say the velocity is negative. You're moving left. That's good enough reasoning. So here's my velocity. Positive values, negative values. We got from 1 to 3 and 3 to 4. I'm not including 3 because that's when I've stopped. What is the acceleration? Positive. I mean, you can immediately say, oh, acceleration is the slopes of velocity. You can look at the slopes of velocity when it's positive. Or you could say slopes of velocity are positive when my velocity is increasing. You can immediately also go all the way to the fact that this is the same as the whole X double prime tells us about X prime. This is the graph of X prime, just like we're used to the graph of F prime. Okay, so you either can look at the slopes of velocity, positive, 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 or the look at the fact that V is increasing to go from 2 to 3. Okay, speed increasing. Let's think about that. Moving right, but increasing in our values, 3, 4, 5, 6, 7. Moving left and getting larger negative values, -3, -4, -5, -6, -7. So what does that look like? We're moving away from the x-axis. That's when the signs of V and A are going to be the same. Look, I got -5, -4, -3, -2, -1, 0. I'm slowing down while I'm moving to the right. I've stopped. I start moving to the left, but 0, -1, -2, -3, -4, -5. Boom. I'm going faster to the left. I'm speeding up there. I'm going away from the x-axis, 1 to 2. -5, -4, -3, -2, -1, 0. I'm slowing down. I'm still traveling to the left. I'm slowing down though. I've stopped. Instead of changing directions, I decide to keep going back to the left. -1, -2, -3, -4. Oh, okay. I'm speeding up there too. -3 to 4. Or what else could you have done if you did your full-on sign analysis from the beginning? V and A, X prime, X double prime. Positives until 1, negatives until 3, negatives after that. You can look at V prime, goes down. This is like X prime is going down. until 2, up until 3, down after that, or look at the slopes of, oh man, I messed that up. Maybe this is not that good idea. A is V prime. This is V, which is X prime. Going down, going up. V is going down, then going up, going down. Going down, going up. A is positive, going down. A is negative. Eventually, you're getting rid of all the X's, and it just makes sense to you. A tells you about V, V tells you about X. X double prime tells you about X prime tells you about X. It's the same deal. Particles moving left, boom. 1 to 3, 3 to 4, or 3 to infinity. Let's say we stop at 4. When's the acceleration positive? When velocity is increasing, 2 to 3, boom. However you got that. Speed increasing, signs of V and A are the same. Boom, boom. Okay? Signs of V and A are the same. All right, we're going to do parts of these free response questions. These are full free response questions. We'll do parts when we know how to do the parts. We'll be able to do every single part of all of these free response questions by the end of the 4th day of this lesson. We're supposed to do A and C without a calculator. When is the particle moving to the left? You're going to say when my velocity is negative. What do I have? My velocity. I need to figure out when that velocity is negative. I need to take my velocity, set it equal to 0. I'm looking from 0 to 12. Now, when is cosine 0? It's probably easy to just figure this out and figure out the values for when cosine 0, pi over 2, 3 pi over 2, 5 pi over 2. If you are having troubles with this, you would then say cosine y equals 0, and then you would say pi over 2, 3 pi over 2, 5 pi over 2, et cetera, et cetera, et cetera. Just be careful, like it might fit, it might not. And then you would solve for t and realize like to give myself a pi over 2, I need to plug in 3. And how you get that, it's like you multiply everything by 6 over pi. And that becomes 3. Plug in, multiply by 6 over pi. 6 divided by 2 is 3. 3 times 3 is 9. Now, if I kept going to 5 pi over 2, just to check, because we might have to check. 6 divided by 2, 3 times 5 is 15. I don't have to worry about 15. I'm looking at an interval from 0 to 12. Okay, so 3 and 9 fit perfectly. This is the graph of, this is the signs of my velocity. We're doing a sign analysis. We are going to plug in test points. It's probably easiest to start not all the way to the right, but to start at like 1. If I plug in 1 for t, the cosine of pi over 6, we're in the first quadrant, that's going to be positive. If I plug in something like 6, that's a good one, the cosine of pi is negative. Then we plug in something like 10, 11, even 12, and we find that we're back in the fourth quadrant where cosine is positive. Okay, sign analysis in its entirety, in its beauty, using trig, great. When am I moving to the left? When my velocity is negative 3 to 9. With reasoning, we have to be ready for reasoning. Reasoning is going to be easy. And part C. We should be able to do part D as well. Find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at t equals 4? Let's do A, C, and D. Okay. Though we'll probably do part D tomorrow, next class. So let's just do A and C. All right, the acceleration is v prime. So v prime equals A. I got to take the derivative of v. Now, to take the derivative of v, I need my friend O and I. So I make sure I take the derivative of cosine pi over 6t correctly. Derivative of cosine is negative sine. Derivative of pi over 6t is pi over 6. So A is actually Negative pi over 6 sine. Yeah, we should do part D. I didn't put it. Nobody's going to do it, though. Maybe you'll do pi over 6t. Plus c? No, I'm taking the derivative. If I was taking the antiderivative, I need a plus c. Okay, this would be the acceleration of the particle at time t. Now, I would want you to have the equation, a of t equals. And if you want to say v prime equals a, that's great. Okay. If you want to say x double prime equals a, that's fine, provided that somewhere you say x prime equals v. Something that we know, but it has to be stated. It's not like assumed to be known. So that would count. And then speed at t equals 4. Okay, this is great. I don't need a full-on sign analysis of acceleration. I already have a full-on sign analysis of velocity. I know my velocity at time 4 is negative. What is it? Don't care. It's negative. I'm moving to the left. Now, a is the derivatives of velocity. So let's see what a is. And that'll tell me if velocity is increasing or decreasing, and then I'll be able to answer. The explanation will be easier than like talking about increasing, decreasing in signs, but I'll just show you. So let's do a of 4, and I get negative pi over 6 sine. Plugging in 4, multiplying by pi over 6 is 2 pi over 3. Okay, I got negative pi over 6. I need to know what the sine of 2 pi over 3 is. It's positive root 3 over 2. How do I know that? Pi over 3, 60-degree reference angle. Second quadrant. Tall 30, 60, 90 triangle. Sine, opposite. Positive root 3 over 2. Boom. Okay. Velocity is negative. The acceleration is negative. Acceleration negative. Velocity is decreasing. Okay. V prime, which is A, negative. V decreasing. Negative velocities that are decreasing, speeding up. I am going to the left, but my velocity values are becoming negative 5, negative 6, negative 7, negative 8. I'm speeding up to the left. Okay. Now, what you would say is that V of 4 and A of 4 have these same signs. Therefore, speed is increasing. Okay, that's it. Part D. We could do this. I need to find the position of the particle. Time 4. How? Well, you are told what V is, and you are told an initial position. We can take the antiderivative. V is x prime. I want x. Let's take the antiderivative. Now, this is good. We got to be able to go both ways. What's the antiderivative of cosine pi over 6t? Well, we start with the antiderivative of the outside, leaving the inside alone, and we would multiply by the reciprocal of the coefficient of t to undo that. You could think about dividing by 1 over pi over 6. Don't forget a plus c. We have x of 0 equals negative 2. X of 0, which is 6 over pi sine 0 plus c equals negative 2. C is negative 2. X of t equals 6 over pi sine pi over 6t minus 2. X of 4 is, guess what? You do need to, I don't think you need to. All you need to do is find what the sine of 2 pi over 3 and leave that as your answer. 6 over pi, sine of 2 pi over 3 I already did, root 3 over 2 minus 2. Leave that. It's fine. Here's your position. Okay. All right, no calculator again. There are some questions that we will have to use our calculators on. This is when we start using our calculators in this unit. Actually, next lesson. Bring your calculator to class next lesson. We're doing A, B, and C. When is particle P moving left? When the velocity of P is negative. I'm not given the velocity of P. I'm given the velocity of Q. I'm given the position of P. Okay, well, I'm going to have to take the derivative of p's position to get the velocity of p. I'm going to have to use an O and an I. I got a log parentheses, and I got a lot of stuff inside that parentheses. The derivative of the log is 1 over. The derivative of that is 2t minus 2. So it's not nice, but this would be the derivative, 2t minus 2 over t squared minus 2t plus 10. Um, I don't like this question because a lot of people are going to waste time trying to solve that equation. Because you should do a sign analysis of velocity, figure out when it's positive or negative. Okay, so we'll get there. But to do that, you need to set the numerator and denominator equal to 0. Now, how do I know this doesn't have any zeros? I mean, if you remember the quadratic formula, opposite of b plus or minus square root of b squared minus 4 times a times c. If this is negative, it's the square root of a negative, you don't have any real solutions, and it is. So the only solution comes from the top, set equal to 0. That happens at 1. Denominator is only going to be positive for any value, actually. Like, try it out. Plug in 0, positive. Plug in 4, positive. So it's all about the numerator. Numerator is positive and negative. When I'm moving left, when the velocity is negative, we're only looking from 0 to 8. So you should have a starting and ending point. Don't be too intimidated with these questions. And you have to do these questions. Like, your quizzes are going to be kind of in this style. Not really. Your test questions are all just for response. A, B, C, D. So 0 to 1 is the answer. It's part A. Part B, when are the particles traveling in the same direction? That's a good question. This is different. Velocities have the same signs. And that's all you have to write. That's your justification. So I already have the velocity of particle P. Let's do a velocity analysis of particle Q. T squared minus 8t plus 15. I'll factor this. T minus 5, t minus 3. And then I only am looking at this between 0 and 8 again. This is the velocity of particle Q. This is x prime. This is obviously x prime, but this was just given to us. We got 3 and 5, which are both to the right of 1, so be careful. Signs will change. So it's very important to have these lined up. This might not be obvious to see unless you have them lined up. When are the velocity signs going to be the same? That's when we're traveling in the same direction. From 1 to 3 and from 5 to 8, my velocities are all positive. All right. And part C. Find the acceleration of q at t equals 2, speed increasing or decreasing. You'll notice these questions show up over and over. Okay, we got q. We have the velocity of q. VQ prime equals AQ. If you want to do x double prime q equals AQ, you can, as long as you say V prime is equal to x double prime. Sometimes that's confusing. We go back to like our beginning. V prime, x double prime, all the same as A. Concavity, curvature, acceleration. 2t minus 8 at t equals 2. Negative 4. That's the acceleration of q. That's negative. That means my velocity is decreasing. At 2, my velocity is positive. My velocity is positive and decreasing. My velocity is going to the right, but my acceleration is going to the left. What's happening? I'm slowing down. Positive 5, 4, 3, 2, 1. I'm going to the right, but slowing down, getting to a stop at t equals 3. So VQ of 2 is positive. Doesn't matter what it is. You don't have to find the value. Say particle is slowing down. You don't have to say because we have a positive velocity that's decreasing. That's fine if you want to do that. Um, you can just say V and A have opposite signs. Okay. All right, next one. All right, we got a calculator. Now, guys, we're going to start using our calculator a lot for the rest of this unit and next unit. Yeah, and next unit. It's important to be able to use our calculator. It goes back to the calculator lesson we had before our midterm, where it's like these are the same questions that we've seen. You're going to graph V, and you have to be able to interpret it. V is X prime. You're like graphing F prime. You got to be able to interpret it. Finding maxes, mins, and zeros. We're going to be doing a lot of it. So, part A is not like that. At t equals 4 is the particle speeding up or slowing down. It actually is because I'll show you. V of 4, I don't know exactly what that is. So I can plug that into my calculator if I wanted to. I'm just going to go ahead and graph V. Make sure your calculator is in radian mode. And I'm going to show you why I'm graphing V. And most of the times for calculator questions, they're giving you V. And the first thing you should do is graph V. Because it's going to be nice to be able to look at. It's kind of like the questions that we did earlier. We're talking about t's bigger than 0, so I'm going to start at a window of like -1. I'd probably just start at 0. Oof, lots of stuff going on here. At t equals 4. So at t equals 4. Now you think this is an x equals 4, but this is like a t, okay? I'm using x's instead of t's. T equals 4. My velocity at 4 is 2.978. Okay? Now, are we speeding up or slowing down? You look at the graph. Probably should zoom in a little bit more. Maybe not go all the way out to 10. Maybe go to like 5. And you can see, but you have to say it. Might not be obvious. That we're going closer to the x-axis, so that means my velocity values are decreasing. See those decreasing values? Well, what's going to be important to do is not just say that the velocity is decreasing, but to find the actual value. V prime of 4, that's A of 4. That's, are we increasing or decreasing? The rate of change of velocity. Is velocity increasing or decreasing by how much? What's the slope of the tangent here? Second, calculate my dy dx. Where? 4. Enter. Yeah, just like I thought. Acceleration is negative, velocity is positive. Slowing down. Why? V and A have opposite signs is all you need. Or you could say, my velocity is positive but decreasing from 2.9 to 2.5 to 2, going to the right but slowing down. Part B, find all the times when the particle changes direction. How are we going to change direction? Well, we got to go from right to left or left to right. What's that going to be looking like? Change of sign of velocity. When does my velocity change sign? When does my velocity equal 0 and change sign, not just like skip off things? So we're looking at when V changes sign. This is the same as when does F have relative maxes and mins? It's the same thing. Changing directions will be a max or a min of position. position thought of as F, maxes, mins of Fs. Okay. From 0 to 3, thankfully. I'm just going to start at 0, go to 3. Now, I have only one location. I have y equals 0 graphed. That's important so that I can find the intersection. You could also do the whole calculate a 0. Boom. 2.707. That's a t. It's literally the same. This would be the location of a what? What's happening here? What are we doing? This is the graph of v. V is positive. X is increasing. My function's going up. It's a 0. It's flattened out. And then v is negative. X is decreasing. Function's going down. Max. A max is when you go to the right or left. It's same. We're reviewing unit 3 as we're doing this stuff. You go from right to left. Position at time t equals 0. You think you can do that? You can't. We're going to find we won't be able to take an antiderivative of v. And that's seems like it's a huge problem. It's like, oh, yes, I can take the antiderivative and then find c. They gave me x of 4 is 2. You can't. We're going to need another way to be able to go backwards, which is why I didn't ask you to do part C. Find the total distance, and we'll get there too. A, C, and D. What's the speed of particle 2? Great question. Speed equaling 2. Velocity could equal positive or negative 2. I'm given the velocity. I'm looking from 0 to 5. I'm allowed to use my calculator. Fantastic. So I'm going to plug in velocity. Negative 2 plus t squared plus 3t to the 6/5. Okay. I'm looking from 0 to 5. And I need to find the values. So you know what I'm going to do? I'm going to graph positive 2, and I will also graph negative 2, one at a time to find the values. So it looks like there's going to be 4. All right, so I got 3.127 ... You need to be accurate to the third decimal place, so don't guess. I'm going to move up to switch to this one, get closer to this intersection, enter. 0.943 ... You don't have to round, I just like to truncate. As well as I know that if I plug in 0, I'm going to have negative 2, so 0 needs to be included. Oh, shoot. 2 to 4. Shoot. I don't need that one. Darn it. 2 to 4. Did too much work. All right, so we got one that's positive 2 at this 3.127, and then we'll have one that's negative 2. Second, calc, intersect, enter. 3.473. Okay. We don't know how to do part B yet. Part C, we'll know after next class. Find all the times in which the particle changes direction. Justify your answer. You literally can just say when velocity changes signs. That's all you need. Now, justifying your answer means like give an explanation. Velocity changes sign counts. We know in the background when velocity changes sign, position will change from increasing to decreasing or decreasing to increasing. That'll be maxes and mins of position. That'll be when we'll change direction. Position's derivative is velocity. It's like it could be a very long explanation. If we had to make it long, we could. Fortunately, we don't have to. Okay, we don't have to say, oh, the derivative of position is velocity. If the derivative of position is positive, position's increasing, which means we're going in a direction that is different than if we're going in a direction. Like we don't just we'll keep it simple. Velocity changes. Okay. 0 to 5. Back to 0 to 5. Changing direction. These are maxes and mins of our position graph. This is the velocity graph. I'm worried that it's coming back, but it doesn't look like it is. Velocity goes from negative to positive. X is decreasing to increasing. We hit a min of my position graph, or I've changed direction from left to right. 0.536. .317. Okay. That's it. Velocity change of sign that's perfect justification. Speed of the particle increasing or decreasing, give a reason for your answer. You're given velocity. What's going on at t equals 4? Your velocity, I feel like I typed it in wrong. No, looks good. My velocity at time 4 is negative 11.475. That means my position's decreasing, I'm moving to the left. Let's look at the derivative of velocity, which is my acceleration. That'll tell me if velocity is increasing or decreasing. Second, calculate dy dx at 4. Negative 22. What is that telling me? Velocity is decreasing. We got velocities of negative 11, negative 12, negative 13. My velocity is getting larger in the negative way. I'm going faster. I'm decreasing concave down, speeding up. This is the easiest justification to do, is just to say signs of V and A are opposite. There are other justifications out there, sure. Here, the signs of V and A are the same. Speed's increasing. Okay, that's the easiest way. You can say I'm moving to the left and my velocity is decreasing. That's fine, but not necessary. Okay, hope this is good. I feel like I'm doing a better job of this than I've done in the past. So hopefully you guys are understanding things. How it's the same stuff we've done. Same stuff we've done. It just looks different. Questions look confusing. Oh, physics. But it's just, when does F have a max or a min? When does F have a horizontal tangent? When is F increasing concave down? Literally, that's all the questions are. Stuff that we've already seen. It just looks different. All right. Hopefully you see it that way. Later. New stuff next class.